Okay, section 8, geometric explicit formulas. So the goal here is to get a formula that you could find whatever term you want. You could find the hundredth term, you could find the thousandth term, and you don't have to find all the terms in between like you would for a recursive formula. I want to start with number 2 because I think it's a little bit easier, just for us to start thinking about it. So for starters, we need to find the info like we normally would for a recursive formula. So we could say, well, what is this? What is the rate? What are they multiplying by? From 3 to 6, we multiply by 2. 6 to 12, another 2. 12 to 24, another 2. So we know R equals 2, right? We could also say, well, A sub 1 equals 3, so that we know where to start from. Now we kind of have to think about what happens whenever we are getting these different terms. Well, A sub 1 just equals 3. That's plain and simple. A sub 2 equals 3 times 2, which is 6. A sub 3, well, we could talk about that being 3 times 2 times 2, which is 12, right? All I did was I took this 3 times 2, and I have it here, and then I put another 2. Same way, A sub 4, we have 3 times, now we're going to have 3 2's, 2 times 2 times 2, which is 24. And again, we've got the 3 times 2, and then we have times 2 times 2. So we're going to use this idea to find our real formula. So let's count how many 2's we have in here. So 2 is our rate. So A sub 1 has 0 2's. A sub 2 has 1. A sub 3 has 2. And A sub 4 has 3. Now what I'm doing here is I'm counting how many 2's we have. Okay? Now, we know that if we have 2 times 2 times 2, we could rewrite that as 8, or we could also rewrite this as 2 cubed, right? If you've got x times x times x, that's the same thing as x cubed. Or if you had x times x, that's x squared, right? So what we're going to do here is we're going to kind of plug in for a variable. We're going to plug in r. We have, well, 3 is a sub 1, right? And then times r. And then we have a sub 1 times r squared. And then a sub 1 times r cubed. Do you see what I'm doing here? I'm taking, here's RA1, and I'm putting them here. And then I'm taking the rest of these, so here's an R, there's an R. Here's 2 R's, R squared, 3 R's, R cubed. That's kind of cool how it made the orange. Now we need to look, we've got, here's a 3, here's a 4, here's a 2, here's a 3. So every time our R is going to be 1 less than what our A sub is, right? So if it's A sub 100, you're going to use only 99 R's. So our general form, or our general equation that we're going to need to memorize or write down and have handy, is going to be A sub n equals A sub 1 times R to the n minus 1. And that's an exponent there. And I put parentheses around the R because when in doubt, just go ahead and put parentheses around them. It matters a lot whenever you have negative numbers. So number 2, our actual answer is going to be A sub n equals 3, or A1, times R, not R, times 2 to the n minus 1. And this is our answer. Okay, and we could kind of think about this. If we were to plug in here, if we wanted to find A5, well, that would be 3 times 2 to the 4th, right? Because I took 5 minus 1 in that exponent. All right, let's look at number 1 and see if we can make sense of this. A1 is 1. Let me change to blue. A1 is 1. R equals, here we multiply by -5. Oop, not -4, -5. R is -5 here. So if we plug into our formula, we have A sub n equals 1 times -5 to the n minus 1. And because it's just a plain old 1 in front, we can simplify this to A sub n equals -5 to the n minus 1. And that's our answer. Number 3, A1 is -2. R here is going to be -3. Let's figure out how I found that. -2 times -3 is +6, right? Negative and negative gives me a positive. 6 times -3 is -18. And then -3 gives us a 54. So we have A sub n equals A1. Here, I'll just write the formula down. That's our formula. And we have A sub n equals -2 times -3 to the n minus 1. So here I got this A1 is that -2, is that -2. And then -3 is that R, is that -3. And this is our answer. Number 4, well, from 3 to 9, I multiply by 3, another 3, and another 3. Right? The more you look at these, the faster you'll be able to find that pattern. Now let's write down what we need to find, or what we need to write our answer. A1 is 3, R is also 3. So A sub n is going to be 3 times 3 to the n minus 1. Now, if you look at this, and there's actually, this is the answer. I mean, you're done. But actually, with having 3 and 3 next to each other, you could make this A sub n equals 3 to the n. But that's just kind of fancy algebra, and you don't actually have to do that. Number 5, what are we multiplying by each time? It looks like 2. We multiply by 2 there, 2 there, and 2 there. So A1 is 1, R is 2. I'm going to write down our formula. A sub n equals A1 times R to the n minus 1. If I plug in our pieces of information, we get AN equals 1 times 2 to the n minus 1. If it's a positive R, you don't really need parentheses. But if it's a negative, you need them. It will not work if you don't have them. And then just like one of the previous problems, since we have a 1 here, and anything times 1 is just itself, we could rewrite this as AN equals 2 to the n minus 1, kind of simplified a little bit. All right, that's number 5. Number 6, what do we multiply each time here? 3 to 18 is 6. Let's check the rest of them. 18 times 3 is, oh, not 3, 6 is 108. And then times 6 again is 684. So A1 is 3 and R is positive 6. All right, these are dots for multiplication. So our formula, I'm just going to write it down. We're just going to fill in. So we get A sub n equals 3 times 6 to the n minus 1. All right, number 7. What are we multiplying by here? Well, from 2 to -8, I think that's going to be a -4, right? -8 to 32 is going to be a -4 again, and then from 32 to -128, I know will be a -4. So A1 is 2, R is -4, and I think we know the formula, so I'm just going to skip that step, writing it down. we're going to have a sub n equals 2 times negative 4 to the n minus 1. And remember, if your r is negative, you need to have parentheses there. All right, number 8. From 17 to 117, I have no idea. Let's say 117, oops, no, 177 divided by 17. If you end up getting a decimal like this, so this says we're multiplying by, I should do a dot, times 10.4. That doesn't seem right. How about 1777 divided by 177? Well, this one's times 10.39. Yeah, this isn't working out. This is a not geometric. Okay. Now there will be some of these peppered in there where they're not geometric. You just have to kind of be on the lookout for it. If you see one that kind of looks funky like this with all the sevens, it's probably going to be not geometric. That's probably a red flag and you need to check. And the way that I check these is I take the second term divided by the first term. That's where I got the 10.4. And then I took the 1777 divided by 1.177 to get my 10.39. Okay. On all of these, you're going to get integer. On all of the ones that are geometric, you're going to have integer r's. These are not integers because they're decimals. Okay, just some different red flags, some things to look out for. All right, that's it.